In this video, I want to talk about graphing rational functions with holes. So anytime you're graphing a rational function, you should always look for if the top and bottom can be factored and if they can be simplified. So for example, in this equation, we can factor the top into 3 times x plus 1. And we can factor the bottom into, okay, we're looking for two numbers that multiply to be -4 and add to be -3. So x minus 4 and x plus 1. Okay, now you'll notice that we have x plus 1 and x plus 1. And if we were doing anything else, we would just say like, okay, let's just cancel those out, right? So you can't quite just cancel them out, except you can and you can't. So it still is the case that if there's an x plus 1 in the denominator, you still can't have x equals 1. So the domain for this function is from -infinity to -1, from -1 to 4, and then from 4 to infinity. Nothing about that changes, so you still can't put in -1 because it still makes the denominator equal to 0, and that is still not okay. But other than that one issue, this function is going to look like 3 over x minus 4. So, except for -1. So, at -1, what's going to happen is there's going to be a hole. So, a hole at x equals -1. That means that we're just not going to have a point just right there. And otherwise, it's going to look exactly like 3 over x minus 4. Okay, so let's go ahead and graph 3 over x minus 4. So 3 over x minus 4 is going to have a vertical asymptote at x equals 4. The degree of the numerator is less than the degree of the denominator, so it's going to have a horizontal asymptote at x equals 0. So let's go ahead and draw those guys in. So a horizontal asymptote here. And a vertical asymptote at x equals 4. 1, 2, 3, 4. Okay. All right, now let's go ahead and plug in a couple points. So at 0, it's going to be 3 over -4, so -3/4 would be at 0, let's see, -3/4 would be right here. Okay, let's actually see what would happen at -1 so we know where to plot that hole. So if -1 existed, it would be 3 over -5. So -3/5. And so x equals -1, y would equal -3/5, which is somewhere around there. But instead we have a hole. It's just a hole in our graph. It's a place where the domain doesn't exist, but the function kind of just goes on behaving normally on either side. Okay, let's go ahead and look at what happens when x equals, let's try 2. So when x equals 2, we have 3 over 2 minus 4, so that's going to be like -3 over -2 is -1.5. So that's going to be somewhere around here. And you can see it's kind of going off toward its asymptote here. Oops, that didn't go very well. Let's see. Going off toward its asymptote there. Not the best graph, but I'll leave it. And going toward its asymptote here. Okay, now let's look at what's happening on this side. So 1, 2, 3, 4, 5. Let's see what happens when x equals 5. We get 3 over 5 minus 4 is 1, so 3. So this should be 3. And then when x equals 6, we get 3 over 6 is 2, so 1.5. Okay, so something like this. So we can see that it's going up toward its asymptote and down toward its asymptote. So the graph will look something like this. So it will look just like 3 over x minus 4, except it's going to have a hole at that one spot. And that is how you graph a rational function with holes. It's important to look in any rational function you graph. It's important to look and see if there are any factors that are in the numerator and the denominator. Those are your holes.